In this video, we'll be talking about similar and congruent figures. So I'm going to make this claim. I'm going to say that these two pyramids are in fact similar. Now, in order for these two pyramids to be similar, there has to be a scale factor that takes one pyramid and maps the measures onto the other pyramid. So what is a scale factor? It's a number that we multiply the measurements by to get the other measurements. So in this case, in order to figure out the scale factor, you'd have to look at two corresponding sides. So this side is corresponding to this side. And so we would have to divide the corresponding sides to see what do you have to do, what do you have to multiply by to get that. So we have to divide to figure out that scale factor. So our scale factor in this case, if these two figures are in fact similar, is 9 divided by 3. Those are the only corresponding sides we have in this example. So our scale factor is 3. All right, that number is extremely useful to us because now it's telling us that in order to figure out every other thing, we would have to multiply by 3 to get the measurements on the other pyramid. So therefore, the width here would be 5 times 3, so that would be 15. And if we had any of these lengths or the height or any measurement, any dimensional measurement that is, we would find it in the same way. We would just multiply by the scale factor, which in this case is 3. So for example, if we knew that this was 8, then we'd have to multiply by 3 once again. So that little red arrow in this case is my little, we're multiplying by 3 sign. All right. And then so we would know on that bigger triangle that that dimension was 8 times 3, which in this case, well, in every case, 8 times 3 is 24. All right. So that is how the scale factor works for similar figures. But for area, surface area, and for volume, some things slightly change. So let's talk about that. Okay, so here we have two cubes, and this time we have a different scale factor. So in order to figure out what the scale factor is, we're looking at what do you have to multiply that by to get to that. You can divide them to figure it out, but in this case it's pretty easy to see that the scale factor is 2. We're multiplying by 2 to get to the bigger cube. Okay, but as I just said, the surface area scale factor will be different. So let's figure out what that scale factor would be here. So if we figure out the surface area of the small cube, hopefully you know how to find surface area because I'm going to do this very quickly. It is 6 times 1 times 1, which is 6. So that's the surface area of the smaller cube. I'll just write SA of the small cube. Is 6 units squared. I'm going to leave off my units because I don't want us to get distracted by the units. And for the bigger square, well, we know, let's see, the front face is 2 by 2. There's 6 of them. So there's 6 2 by 2 faces, which is 24. So the scale factor then, and I'll use a different arrow, the scale factor going from the area of the smaller one to the area of the bigger one is actually 24 over 6, which is 4. So our scale factor was 2 for the dimensions, but 4 for the areas. The reason for this, and this is an important point to note, so you can write this down, the scale factor of the area is always the square of the scale factor of the dimensions. I'll write it down. Scale factor of the area is the square of the scale factor of the dimensions. So that means if the scale factor for the dimensions were 5, then the scale factor of the area would be 5 squared. It would be 25. Or if the scale factor was 10, if one one length was 10 times the other length, that means the area would be 10 times 10, so 100 times the other area. So the scale factor, again, is always the square. For area, it's always the square of the scale factor for dimensions. Okay, cool. So let's look at volume. Okay, so I brought back my 2 cubes, and they're pretty easy to work with. That's why I brought them back. So again, my scale factor, going from 1 to 2, the scale factor is 2. We're multiplying by 2. But I know that it's probably not going to be the same scale factor with volume, so let's just check. So the volume of the smaller cube is going to be 1 times 1 times 1. I'll write that out, which is just 1 cubic unit. And I'll leave the units off because I don't want them to distract us. And the volume of the bigger cube is going to be 2 times 2 times 2, which is 8 units cube. So now, going from 1 to 8, our scale factor has clearly changed. Now, our scale factor is 8. So what is the relationship between the scale factor of the dimensions and the scale factor of the volume? Did you manage to pick that up? Well, if not, I'll let you know. And this is super important. The scale factor of the volume is always, 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 always the cube of the scale factor of the dimensions. And I'll write that down because it's so important. So the scale factor of volume is always the cube of, whoa, my pen is going out, of the scale factor of the dimensions. All right, so that means if my scale factor were 3 for the dimensions, then the scale factor for the volume would be 3 cubed, which means the scale factor for the volume would then be 27. If my scale factor for dimensions were 4, then my scale factor for volume would be 4 to the 3rd power. So it gets much bigger, much faster, the volume does. All right, so let's look at a quick example, and then we'll really briefly talk about congruent figures and then wrap up. All right, so here we have it. We have the side length of one cube is 1.5, and the side length of a second cube is 4.5. And so the first thing that I want to know is what's the scale factor of the dimensions. So the scale factor of the dimensions, we can just take one side length and divide it by a corresponding side length, and since it's a cube, all of the side lengths are corresponding, so that's fine. So we just divide our 4.5 by 1.5, and we get that our scale factor is 3. This means that each length of our cube will be 3 times as big in the second cube. So the second cube is 3 times as big when you're looking at the lengths. But when you're looking at the areas, the scale factor of 3 will have to be squared. So the areas, the bigger cube is 9 times as big as the smaller one when you're focusing on the surface area. But when you're focusing on the volumes, the scale factor, the original scale factor is cubed. So our second cube will be 27 times bigger than our smaller cube. The second cube, when you look at the volume, is 27 times bigger. So I think that's pretty interesting, and that's how scale factors work when it comes to volume and when it comes to surface area, when it comes to dimensions. All right, finally, I just want to give a brief look at congruent figures. They're actually pretty simple because congruent means that they're the same size, they're the same shape, they're the same everything, same angles, same everything. So you don't have to wonder about the surface area, the volume, any of that stuff. If it's congruent, every single thing is the same. And that's it for now.